Hello, guys. Welcome to another episode of Cuda Education. Today, what I want to do is focus on compilation. Okay, so we're just dealing with compilation of the render pipeline. All right. In the previous episode for Apple Metal, we talked about um, compilation, render pass, and things of that nature. Um, what I want to do here is focus on the compilation of the pipeline, right? The render pipeline. We have a render pipeline that has all of our stuff on it, and we want to compile our render pipeline down to machine language, right? So we could pass it on to the GPU, and the GPU understands the instructions that we're giving it. In order for us to do that, we have to compile the render pipeline. We could just call it pipeline going forward, but it's the render pipeline, right? And the render pipeline is just sort of the the meeting agenda, the assembly line, the list of tasks that we want to get done, organized neatly for the GPU to understand. But not only do we have to create it in human readable form, but then we have to do a compilation process so it goes down to low level machine code so that the GPU on our system can actually understand what we're talking about. Okay? So this right here is our goal, right? We're going to instantiate a render pipeline state, and then we're going to compile it with a bunch of information associated with it, right? The reason I sort of start with this is because there's a lot of things going on, and it's sort of divided up between two files, and we're doing, it's a lot of jumping around. So in order to anchor you guys, um, I'd rather just start with this, and then we'll work our way backwards or work our way around, right? So couple of things to note. This compiler handle, we're gonna have to dive into that. This descriptor handle, we're gonna have to dive into that, right? So we have a compiler, we have a descriptor. Descriptor has all of our settings and our configurations and stuff like that. Compiler task options, it's an optional thing that I'm not really gonna get into, but maybe at the very end I'll just mention it. But it's not the focus of anything, and it's optional. And then we have a simple error placeholder that like doesn't really mean anything. It's just a reference to an error instance the compiler assigns if it can't compile the render pipeline, right? So if the operation fails, this is the error that you give, right? And we just have it as a placeholder, so that's not a big deal. The two big things that we have to focus on is compiler and this descriptor, right? Along the way, we're going to dive into some other stuff, but I want you guys to understand what the end goal is. The end goal is to compile our render pipeline, or compile our pipeline into machine code, so that the GPU on the M GPU can compile, M4 GPU can compile. The M4 GPU can read our instructions and run our application and all of that good stuff. For those that might not be familiar, this is our application. We have a triangle that's rotating with color gradients, 3 vertices. That's our application, right? If you've been following the channel, you've seen that several times, right? But the heart of the matter right now is to figure out how to get all of this stuff together, right? Compiler, descriptor are the two main things, and then there's some other things along the way. Not too worried about these two. This is just a placeholder for an error message. So the two files that we'll be working with is the current file, which is Metal 4 renderer compilation, right? So the Metal 4 renderer compilation file, and this actual call that we're working with is inside of the compile render pipeline function. So we'll get into all of that, but this call to basically do the compilation is inside of compile render pipeline. Go figure, right? And there's a bunch of stuff that goes on with that. We'll get into that. So let us start. I figure the best way is let's start right. So the Metal 4 renderer dot plus compilation file is is sort of where our goal final statement lives. But the other file that we will be working with is also, not sure if you guys can see it, but it's the Metal 4 renderer, right? So the Metal 4 renderer file. So the Metal 4 renderer file and the Metal 4 renderer plus compilation file, right? So those are the two files that we're going to focus on for today. All right. All right. So let us let us start from the very, beginning of this conversation. So again, we want to get to here where we're able to compile the pipeline, right? But we're going to start in the Metal 4 renderer file, the .m file. Okay, so in there we have a function. Where is it? Where is it? Is it this? Okay, right. Okay, so right, this is the Metal 4 renderer file. And we have init with metal kit view. Okay, so let us just go through what this function is just so we have a little context. Okay, initializes the Metal 4 renderer with a metal kit view, and it comes with a parameter view. Okay, so we have a init with metal kit view, and then the parameter is view that it consumes, right? MetalKit views have convenient methods and properties that provide context, including a pixel format which the renderer needs to build its rendering pipeline, and then a CA metal drawable instance which provides a rendering destination. Not going to really worry about the second one. We're going to touch on this first one, but let's stay focused. Okay, so we have this init with MetalKit view. Basically, it's initialize the Metal 4 renderer with the MetalKit view, right? So as you guys know from previous episodes, we create a view. The view kind of is like a window and all that stuff, but then eventually, the inside of the view we want to draw stuff, and because we need to draw stuff, we need a renderer to draw the stuff, right? In our case, it's a Metal 4 renderer, right? So we need to draw stuff. So that is why initialize the Metal 4 renderer with the MetalKit view, right? So we're now trying to associate the Metal 4 renderer with the view. What we care about in all of this is this guy right here. Retrieve the metal device instance from the view, right? This piece right here, right? So we got view.device, right? And this piece right here is this dictates what compiler is used based on the device associated with the view we are working with, right? So, basically this is the compiler associated with the M4 GPU that is on my system, right? So we now have an association with a device, and that device has a particular compiler that it uses in order for you to get compilation stuff, right? In order for you to get, for you to basically interface with the device, so that you could take your instructions, push it through the push it through the compiler and get your instructions into machine code so the GPU can actually run it. Okay. Okay, and then before leaving this file, so we're still on the M4 renderer file .m, right? Just on the .m file, Metal4 renderer.m. We're not in Metal4 renderer compilation.m. We're just in the Metal4 renderer.m file. Before leaving this file, we need to request a compilation of the render pipeline state for the view. Okay, so we already chose a device here. Okay, and now we need to request a compilation of the render pipeline state for the view. Okay, so within the same function, init with metal kit view, initialize, and again, this function is initializes the Metal4 renderer with the metal kit view, and the parameter is the view, right? In order for us to do that, we have to continue down in the function, and we're going to stop right here. Compile a render pipeline state for the view. So we have render pipeline state equals self compile render pipeline, and what does this compile render pipeline function take? It takes view dot color pixel format. Okay, so render pipeline state, compile a render pipeline state for the view. So basically what it's saying is like, listen, this view needs a pipeline, and that pipeline needs to be compiled. This view needs a pipeline, and the pipeline needs to be compiled, right? So we have a variable called render pipeline state equals self compile render pipeline, and then one of the parameters for this function is the view.color pixel format. Okay, now one of the things I don't really like about how this code is built is that they sort of reuse the same name. So this name is also the same name that we use in the first file we looked at, and I don't really like that because it's kind of confusing. Because variables have scope, right? So this scope is not the same. It's not the same variable or the scope that's in the original file we looked at, right? But I digress. Okay, so we have to compile a render pipeline state for the view. So basically, the view needs a pipeline, and that pipeline needs to be compiled, right? That view has a pipeline and it needs to be compiled, or it's given a pipeline and it needs to be compiled, right? So that is what this guy is right here. Now we're just gonna go on a brief tangent, relatively minor tangent, but this view.color pixel format, right? So if we go to the definition of this view.color pixel format, basically we get to here, which is MTL pixel format, color pixel format, right? So color pixel property, color pixel, the pixel format for the drawables texture. Okay, I just wanted to bring it up. It's not a point of focus necessarily. This particular piece is not a point of focus for us right now, but just know that this is in the mtkview.h file, which is like a whole nother file tree and file directory stuff, right? But this is where this variable is initialized. Just wanted to touch on that, but we're not gonna get too bogged down with it, right? So we have compiler render pipeline state for the view, right? So now this compile render pipeline function, which takes a parameter view.color pixel format, we have to run that in order to get our compiled pipeline for the view. I know this is a tongue twister, guys. I'm sorry, but I'll just say it one more time. The view needs a compiled pipeline, render pipeline. The view needs a compiled render pipeline. And we are going about creating that by basically running compile render pipeline function and with the parameter view.color pixel format, okay? So this compile render pipeline function now is going to bring us back to the other file that I said that we were going to investigate, and that's Metal 4 renderer plus compilation, right? And here, sure enough, compile render pipeline, right? So we are now inside of the compile render pipeline function. Let us just look at the information that it's given to us. Creates a renderer's pipeline state that works with a specific pixel format. Parameter, the parameter it needs a color pixel format. A pixel size and layout configuration, the method applies to the renderer's pipeline it compiles. I'll say it again. Color pixel format, parameter color pixel format. So see, we have our function here, and then the parameter that it consumes is the color pixel format. A pixel size and layout configuration, the method applies to the render pipeline it compiles. So that's that. Okay, so we do have our compile render pipeline situation, and we have to dissect what's going on here. Again, just to reiterate, the goal is to get to here, right? We wanna actually compile the pipeline. Okay. So in order to achieve our goal, right, we have to build things. Okay, so first thing we need to build is we actually need to build a compiler. So a Metal 4 compiler instance with a default configuration. A Metal 4 compiler instance with a default configuration. So remember I said that this was a talking point, right? So we have to right, so we have to actually we have to actually create an instance of a compiler, and this instance is going to have the default settings, right? So let us go now into this create default Metal pipeline. So we have ID MTL4 compiler, the variable called compiler equals self create default Metal compiler. Okay, so let us go to that function. That function actually lives right inside of this file. So if we look closely, we'll see that literally this create default Metal compiler is inside of the same file. Now we have our compile render pipeline function, which starts here and then ends here, but then we have our create default Metal compiler, right? And basically we go through all of the all of the things needed to actually create the default compiler, right? So error is nil, compiler equals self.device, new compiler with descriptor, MTL4 compiler descriptor new, error, what have you. Notice that it's a similar format where, we're basically, listing out arguments for the new compiler with descriptor, MT4 compiler descriptor, error is this, and then if nil equal compiler, right. So if we get a if the Metal device, if the GPU can't create a compiler, then we get this error, right? Otherwise, so this is just the error processing. Otherwise, we return the compiler. So we have our compiler here, and literally it's just this function call, right? New compiler with descriptor, MT4 compiler descriptor, and we return the file, right? Assuming that there was no error, okay? And once we do that, we now have our compiler instance, okay? Not too hard, right, guys? We have our compiler instance. So that's that. So that's this piece right here. And then the second thing we have to figure out now is this descriptor conversation. So let's dive into that. A configuration for the render pipeline the method compiles. So basically, this is the configuration setting, right? So we want to compile a pipeline, but we need information on like what does the pipeline have, what is the information it's dealing with, etc., etc. So we have this MTL4 render pipeline descriptor and then descriptor, right? So we initialize this variable, and then this variable descriptor equals self configure render pipeline color pixel format. So notice that it consumes the same variable that was given to compile render pipeline. So configure render pipeline takes the same parameter as compile render pipeline, right? The color pixel format. This is the reason why compile render pipeline needs this parameter. It needs color pixel format because it's passing it to configure render pipeline, right? So let us investigate configure render pipeline. Configure render pipeline is also within the same file. It's another function. So just like how we had create default metal compiler as its own function, we also have configure render pipeline as its own function. Okay, creates and configures the renderer's only render pipeline. Creates and configures the renderer's only render pipeline. Okay, so here, and the parameter is color pixel format, right? So an output data format that the new renderer pipeline produces, right? So color pixel format is sort of, you know, where all of the information that we're working with gets baked into. An output data format that the new render pipeline produces, right? So we're now configuring the render pipeline. Now within that, we do a bunch of stuff. We initialize render pipeline descriptor new MTL4 render pipeline. Render pipeline descriptor.label is basic metal for render pipeline. Okay, so we have a label associated with it. I believe these labels are for like in the debugger and when you're analyzing stuff, you could actually, you know, you could know which descriptor this is for. So basic metal for render pipeline. Okay, so within that, so we now have render pipeline descriptor. Now set the pixel format, the vertex shader, and the fragment shader for the configuration. Okay, so the pixel format, color attachment, pixel format is color pixel format. So it's basically the same thing we've been passing around. Okay. We'll leave that alone. And then render pipeline descriptor, vertex function descriptor equals self make vertex shader configuration. We'll investigate that in a second. Render pipeline descriptor dot fragment function descriptor equals self make fragment shader configuration. Okay, so you know, we're baking in all of our settings, namely the vertex shader configuration, the fragment shader configuration, and we're just passing through the color pixel format. And we return, once we're finished with this function, we return render pipeline descriptor. So basically this render pipeline descriptor that we're returning goes into it basically goes into this descriptor right here, right? And this descriptor is what we use right here to actually compile the pipeline. Okay, but let us dive into these functions. So make vertex shader configuration, right? So if we go to that definition, it's basically literally another function right underneath in the same file, another function right underneath it. So make vertex shader configuration, and we have a bunch of instructions, dealing with that. I don't want to dive too much into this right now, but creates a library function descriptor for the app's vertex shader. Xcode compiles the vertex shader GPU function in the shaders.metal source code file into the app's default library. I don't really want to dive into this too much right now. I really, but just know that this make vertex shader configuration, this is inside of the same file, and it's this function. We have it for the vertex shader configuration, and we have it for the fragment shader, make fragment shader configuration, right? We'll read the description for this. Creates a library function descriptor for the app's fragment shader. So here's the vertex shader, fragment shader. Xcode compiles fragment shader GPU function in the shaders.metal source code file into the app's default library. At some point we will dive into this, but in the name of simplicity and straightforwardness, I don't know if I want to dive into this too much right now. Let us see. Okay. So shaders.metal. So shaders.metal. Okay. So we have fragment shader, a basic fragment shader that returns the color data from the rasterizer without modifying it. Return the color the rasterizer interpolates between the triangle's three vertices, right? So that's that for the fragment shader. And then let's see. And for the vertex shader, a vertex shader that converts each input vertex from pixel coordinates to clip space coordinates, right? So we have vertex shader, and we have a bunch of stuff, right? But that's all boiled into here and here. I believe, because if I go to is it the name that drives? Yeah, I don't even want to, I'm not sure if it's the name that drives. Yeah, we're not getting into all of that. But I believe, we have fragment shader, and vertex shader, but these are the guys that's inside of, that's our shaders.metal thing. So anyway, guys, let's not lose focus. So we basically, these are the functions that does the configurations for the vertex and the fragment. Remember, fragment is usually color, and vertex is dealing with the vertices of the triangle and transferring it from local space to clip space and all that stuff, the coordinates. But anyway, so we have, our configure render pipeline, which basically calls the make vertex shader configuration and make fragment shader configuration. We boil that into, we return it, we return we return our results, and that gets baked into our descriptor, okay? And then that descriptor is basically called here, And once we do that, we get our return pipeline state. So we get our compiled render pipeline. Again, I don't like the idea that this variable name that we use internally is the same as the variable name that we use for receiving the compiled pipeline. Because this is an internal, they should have named it something different, but we'll leave that alone for now. Anyway, guys, so we have our descriptor, we have our compiler. Compiler task options, basically an optional configuration that stores references to binary archives. So this is like if you have a previous pipeline that was compiled, you could I guess you could save it to disk or something, save it to a file, and instead of having to recompile, which is expensive, you could just use that previously compiled pipeline. But it's an optional thing, and I don't really want to spend too I don't really want to focus on that right now. We'll leave that alone. And then we have a placeholder error error thing, which is a reference to an error instance the compiler assigns if it can't compile the render pipeline, right? And once we run this and then we return, because remember guys, we are in compile render pipeline, and once we return that, we get back to our renderer. Where are we? So once we return that, then we're basically good. We have our right. Once we return that, we have our rendered pipeline, compiler render pipeline state for the view. So this is basically now, we now have our compiled render pipeline. And then does this get consumed somewhere? Yeah, we have our compiled render pipeline. And then we consume that with other stuff. Configure encoder with the renderer pipeline state. So we associate that with the encoder. What is this function? Yeah. All right. Yeah. Let's not get too. So you guys, pretty much you understand, the whole gist of the thing. So the compiler is associated with the device that we decide to attach the view to. We basically we request a compiled render pipeline for the view, and this request right here triggers all of the stuff that we have here, right? And we basically run our compile, we run our compiler. If there's no errors, we return the compiler, and then we now have a compiled render pipeline. All right. So that's the topic for today, guys. This is Cuda Education. This is the Hello Triangle app. This is the Hello Triangle app, guys. So if you want to be able to run, if you want to be able to follow along, you could get the Hello Triangle app. it's metal sample codes. You can look it up, and it's a Hello Triangle app. And you'll be able to basically you download Xcode on your Mac. You download the Hello Triangle app, and then you open up the project file, the Xcode project file in the app. You try to run it. It's probably going to give you an error about running signed locally or signed in development. You got to change it to run locally, and then you'll be able to run the you'll be able to run the app, and you'll get your triangle, right? And once you get your triangle, you could follow along in the code and learn all this stuff. So just to reiterate one more time, guys, we basically follow the process of compiling a pipeline, a render pipeline for a view. Okay, so when we compile the pipeline, we basically now have our instructions in a format that the GPU can understand and therefore run. Just to reiterate one more time, so our vertex shader is what gives us the vertices of the triangle. So we have 3 vertices, and the fragment shader is what gives us the color. So notice that for each vertice there is a color associated with it, and then they kind of blend in the middle. Okay, so those are all the instructions that are baked into the pipeline. And once we have it baked into the pipeline, we compile the pipeline so that the GPU can render and draw our triangle and push it to the screen. All right, this is Cuda Education. Thank you for watching. Have a great day.